Okay, hello, I'm Jakub. I'm from OpenShift Test Platform team, and I have a small lecture about optimizing workload management in a multi-cluster environment. Important thing to say is it's a case study, so it's based on our example, but I hope that you can take something out of it. Maybe some patterns will be familiar. So let me start with saying what OpenShift CI is. It's an ecosystem that is consisted of multiple clusters. They are configured to host tooling and provide CI services for over 1,000 GitHub repositories. A little bit about our history. So we started as a single cluster environment. I believe it was on AWS. It was mostly infra cluster that hosted some load. Then time was passing and we switched to the multi-cluster environment. We had 2 clusters at the beginning. We are talking about a time span of, let's say, 5, 6, maybe 7 years since the start of the journey. So somewhere in the middle, we switched multi-cluster, and we hosted 1 cluster for building on AWS, and then second one on GCP. Then we started to grow because more load, more things to do in the CI, and we attached additional clusters, mainly on AWS. So we have infra clusters, several build clusters. We have also Hive and HyperShift deployment, and we have cluster pools. And finally, we are coming to nowadays, and now when we speak about our platform, we have multiple clusters, mainly on AWS. The reason is that AWS is cheaper than GCP. And we have Hive, HyperShift, cluster pools that are connected to the Hive cluster. And important thing is also that besides that, we have something that is called ephemeral clusters. This is an entity of the test. Our users create them ad hoc, and they are destroyed after the test. They are mainly for end-to-end testing. So our users monthly invoked over 500,000 of tests, and they are creating a bunch of ephemeral clusters for the purpose of end-to-end testing. And this is more or less our platform nowadays. So I presented here a journey that started from single cluster environment. We went then to the multi-cluster environment with some redundant clusters. And right now we are in a multi-cluster environment with replaceable clusters. So of course we can talk about pros and cons of every solution, but we have short time today, so I selected only 1 pro and 1 cons that we can present here. So if we go to the single cluster environment and study it, there is a simplicity. That's a big plus. But then if the cluster is, for example, mistakenly deleted, there is no CI. And it happened. It actually happened in the past. So going from that direction to multi-cluster environment, we had 1 infra cluster and blob clusters that, I don't know, let's say 5 or 4 clusters that were sustaining the load. If 1 cluster dies, you can handle it, but if 2, we were in trouble. So, of course, we had higher fault tolerance, and the infrastructure was, by the way, more complicated. And right now, we decided to have more clusters. We have around 10, maybe 11, maybe 12. I don't remember right now exactly. Way more than 4, yes? And we have right now, if we analyze the situation, the best fault tolerance in our history. But of course, it's very hard to manage those clusters without proper automation. So reasons for going multi-clusters is that we want to be agile. We want to isolate clusters with failures and keep running CI services for over 1,000 repositories. We want to scale. And we also need flexibility. Some tests are running on AWS, some tests are running on GCP. It's more efficient to attach them to the clusters running on those providers because of, for example, costs, collocation. Yeah, we want to cut costs, of course. So what is the problem that I would like to discuss today? The problem is how to distribute workload across all build clusters efficiently. And the solution, of course, as I noted in the previous slides, is automation that takes under consideration every detail. And in our case, it distributes jobs periodically and during failures, during outages. During outages, we have the possibility to detach the cluster, distribute the load, and live with it. Yeah? So the question you may ask is why we are dispatching workload periodically. There are some arguments for that. We can't work in real time due to multiple factors that are contributing to our algorithm. Those that are the inputs to the algorithm. And for example, why periodically? The answer is first argument, so namespace preservation. If somebody builds a test, for example, for pull requests, there are some artifacts. We don't want all the artifacts to be recreated every time we rerun tests. So this is why we need this namespace preservation, because all the artifacts, they reside in the namespace, which resides on certain clusters. It's a certain cluster. So it would be inefficient for us to change this cluster. This is why we are not assigning workload in real time, but rather pre-assigning, yes? Another arguments which are inputs to the algorithm is, for example, collocation. I was speaking about a minute ago that some tests are more efficient to run on AWS where they are based on AWS, and the same goes for GCP or other cloud providers. We have, of course, cluster status, so that means load and capacity. We can also detach cluster if it's under failure. There is another factor, which is architecture compatibility. We enabled the possibility to be multi-arch, so we are taking that as well under consideration. Very important factor is job history. We are using Prometheus to analyze historical data and assign jobs accordingly. I will speak a little bit more about that in the next slide, as well as cluster capabilities. This is new for us because generally we assign capabilities to the cluster. For example, this cluster can sustain multi-arch. It's connected to the intranet. Unfortunately, not every cluster in our infrastructure is the same, and probably in our next history, we won't reach the point where we will have all the same clusters. It would be the best, because then we don't need capabilities. But unfortunately, right now it's not possible to make every cluster the same. The reason, for example, is collocation. So here is the visualization of that. We have dispatcher algorithm, which is accepting all the inputs and then periodically or during outage distributing load to the clusters, to the build clusters. Speaking more about capabilities, we have capabilities config file here. So we have AWS. For example, the cluster is build 1, and capabilities assigned to the clusters are ARM, GPU, build StemFS, high performance, and others. So we define those capabilities, and users can assign the capabilities to their workloads if needed. We work to develop more and more capabilities over the time. When we speak about history, so we analyze record count. This is our case because we can imagine that if we take just the whole number of tests, some of them are executed more frequently, some of them are less frequently. So we are analyzing record count. But if you want to have a more sophisticated algorithm, you could also analyze execution time and count that into your equation, into your algorithm. So generally, what algorithm is doing is analyzing input parameters, and jobs within the same repository are typically assigned to the same cluster. This is also input to the algorithm. It's more efficient to have everything on one cluster. Changes, they are committed immediately after job execution. So we assign cluster, and when the algorithm assigns cluster, the job is assigned. That goes to the persistent volume claim for the history, but also we are writing a copy of that into GitHub repository for legacy reasons. And important thing for us, which is not yet fully achieved, is that users cannot modify the cluster assignment manually. It's not yet achieved, but it was a big problem in the past that users were going into the repository, manually assigning clusters. And imagine cluster fails, there is an outage, and we have a whole bunch of questions why my job is not working. It's not working because it's manually assigned to the failing cluster. Short slide about evolution. So naturally, the number of clusters will continue to grow as platform scales. And we see this as a natural thing, and it will happen in the future. Clusters may offer more diverse capabilities over time. So there is something about AI, so we need GPU. There is something about strange cloud providers, so we may need that. In the future, it would be the best to have, of course, every cluster the same, but of course, because, for example, provider is not the same, it cannot be achieved. We want to get rid of static cluster assignment. This is the point that I was discussing in the last point here. And finally, the very important piece that is missing right now, and I was silent throughout the whole presentation, but it can happen because we don't have redundant infrastructure, and we want to achieve that as a next step. So now it's missing, but I hope that in the future, maybe in the time span of 1 year, we'll achieve that, because if our infrastructure fails right now, we are in big trouble. Unfortunately, it's not that easy because it runs all the services, and it's very hard to recreate it. And that's it. Thank you very much.